Okay. OSPF, Open Shortest Path First. This is very largely deployed routing protocol. Open Shortest Path First. You see, Open O. That's what O stands for. Shortest Path First is an algorithm which is not a routing protocol. It's an algorithm designed by a man called Dijkstra. Dijkstra. You might have heard about this name, Dijkstra. Have you?
Yeah, Dijkstra's path algorithm,
Yeah,
right?
correct. Dijkstra's shortest path first algorithm. Dijkstra's shortest path first algorithm. Dijkstra's algorithm. So that also has got another name. That also you might have heard. Binary tree algorithm.
Didn't hear that. Yeah.
Binary tree algorithm. It is nothing but the shortest path. Shortest path. Why they call this binary tree? True or false? That's all. Binary. True or false. Is this path cheaper? Yes or no. There are two answers. Yes or no. If yes, go that way. If not, don't go that way. That is why it is called binary tree algorithm. So open, the meaning why open is given here. The word open, what does it mean? It means that this is a routing protocol which is an open standard.
Okay. Yeah. Open source.
Open source. Open standard. No proprietary. Open standard. But SPF is not a routing protocol. SPF is just a algorithm. Dijkstra is not the designer of OSPF. This is as per the RFC standard. It's not Dijkstra. It's only Dijkstra's algorithm being followed in this. In OSPF, Open Shortest Path First. Now, this protocol comes under the category called link state protocol. Link state. You remember what EIGRP is? It's a distance vector, advanced distance vector. Advanced distance vector. OSPF is the link state routing protocol. The reason why we call it as link state routing protocol is instead of advertising the routing table like EIGRP and RIP, what they do, they advertise the routing table. What is there in the routing table?
Yeah. The routes which is directly connected or
will you have
from
all
other
possible
routers?
routes or only the best routes? Correct. So if a router is advertising the routing table, which means they're advertising only the best routes. What about the other routes? They don't, isn't it? They don't. But link state routing protocol, they don't advertise routing table. They advertise every link on the routers and their status. Every link information will be shared with all other routers. So, correct. The link which is up, which is not shut down. The link which is up, the link state routing protocol advertises link status. The link which is active, how much bandwidth is there, and what subnet, what is the IP address, what is the subnet mask, and what is the cost on that link for OSPF. Okay, the cost is nothing but the metric. OSPF calculates the cost automatically based on the bandwidth. We call it as auto cost. Automatically cost is calculated based on the bandwidth. When the bandwidth is high, cost will be low. Yeah, when the bandwidth is high, the cost will be low. So do you hear me? Less cost, more bandwidth, less cost. So the path with low cost is what always preferred.
Less cost.
Which means what? OSPF is going to choose the path with more bandwidth, high bandwidth, path with more bandwidth. Yeah. So open shortest path first is a routing protocol, which is link state routing protocol. The reason why you call it as link state is the link state information is advertised by every router to all other routers. Using that link state information, each router builds a database. We call it as LSDB, link state database. LSDB. You can see that in this picture here. This link state database is built by collecting LSAs. What is LSA? Link state advertisement.
Yeah, right.
So no. Switching only BPD. In switches only STP uses BPD.
Right? Here it is LSA, right?
Okay. No. Only STP will use BPD, spanning tree protocol, which is our switching.
Okay.
Any so other BPDs are only used by STP, RSTP, MSTP. Only they use BPD.
Yeah, right.
EIGRP uses advertised distance. Sorry. Yeah, correct.
Yeah.
EIGRP uses the advertisement that comes along with the advertised distance. RIP uses the advertisement which is sent periodically every 30 seconds. And hop count is the metric. Now, God bless you. LS link state advertisement is what this link state protocol OSPF uses to find the best path, the low cost path. You see, the low cost path is what considered as the best path for every destination. A low cost path is discovered, found, and installed into the routing table. A low cost path. So who is picking the low cost path? From where it is picking? SPF algorithm is the one which is going to pick the low cost path. And from where it picks? It picks from the LSDB. How LSDB is built? By collecting LSAs, link state advertisements. See, this is how OSPF works. That's why we call it as link state routing protocol.
LSDB.
Link state routing protocol, because the link state advertisements that are sent between the routers helps the routers to build a database. And this database is referred by SPF algorithm, and SPF algorithm picks the shortest path first and puts the path into the routing table. So it is the LSA, the basic building block is LSA, link state advertisement. That's the basic building block. Yeah. So without LSA, there is no OSPF. So SPF is not a routing protocol. SPF is just an algorithm.
Yeah.
LSA is very important. That is why we call it as link state routing protocol. Now this OSPF has got 3 tables. Same like EIGRP, no? EIGRP also got 3 tables, right? Neighbor table, topology table, and routing table. Same like EIGRP, OSPF also got 3 tables: neighbor table, topology table, routing table. Now, what is there in the neighbor
Yeah.
table?
Yes.
The neighbors with which OSPF has successfully established neighbor. See, to form successfully neighborship, to form neighbor successfully, there are some parameters that need to match between the neighbors. There are some parameters that need to match between the neighbors. What is that parameter? Hello packets carry things like router ID, area ID, authentication type, authentication string, and etc. So let me come to those things later, parameter thing. Now what I want to say here is, it's not simply going to form a neighbor. It is not going to simply form neighbor. It is going to form neighbor only by sending hello packet, and in the hello packet certain parameter need to match. Only after that the neighborship get established. All right. So about the hello packets we'll see later. See, AGRP sends hello packet. Do you remember? AGRP sends hello packets. How often they send hello packet?
Yeah.
Correct. Every 5 seconds, AGRP sends hello packet. OSPF, 10 seconds.
Yeah, right.
Every 10 seconds, OSPF will send hello. Every 10 seconds.
5 seconds, right?
Every 10 seconds, OSPF sends hello packet. In AGRP, after how many seconds a neighbor is considered as dead?
10 seconds, right?
Correct. In OSPF, it is 40 seconds. 40 seconds. So OSPF sends hello every 10 seconds. If a neighbor, if a neighbor established
15
neighbor
seconds.
stops sending hello after 40 seconds, the neighbor is considered as dead. A long period to decide whether neighbor is dead or not, it takes 40 seconds. See, you no need to leave it default. It's up to you. You can change the timer. If you say 40 seconds is too long, I want it to decide as soon as possible. Yeah, you can go and change it, but the problem is the timer should match to form neighbor.
Yeah.
If you change the timer only on one router and forget to do it on the other router, the neighborship will break. Because every 10 seconds they send the hello packet with the timer information. In the hello packet, they send the timer information, and the receiving router will compare the local router's timer and the neighbor router's timer. When they don't match, the neighborship breaks. So what do we understand? Neighbors are established only after checking certain parameters, which we'll see later. Those neighbors with which the parameters all matched, those neighbors with which OSPF is comfortable to establish neighbor, they are all maintained in a table called neighbor table. This neighbor table is also called as adjacent database because they are all adjacent. They need not to be physically adjacent. You can establish OSPF over the tunnel also. If there is already a tunnel interface, you may have OSPF. So whatever, whether it is physical or virtual, they are all adjacent. They're all connected either via physical link or via the tunnel virtual link. And to
Yeah.
maintain the neighbor, OSPF keeps sending hello every 10 seconds. Next, about the topology table. For every single destination, the all available paths are maintained in this database called LSDB. This LSDB is what we call it as topology table. We saw in the previous page LSDB, link state database. This is the one. This is the one. All possible paths, because it's a link state routing protocol. See, in EIGRP, you cannot guarantee all possible paths. Why? Correct. Because the routers advertise only the best path. You cannot guarantee that all I have known is what we really have. So
Yeah.
the best routing protocol,
It is having
which
all the
will
possible
give you the complete picture of topology, is the OSPF. That's why it is considered as best. And it is widely seen in service provider environment as well as the enterprises environment.
Only best path it will be.
It's very popular protocol. Very popular. Highly deployed one. So topology table is also called as LSDB, link state database. This will have all possible paths for all destinations, all networks. Now within an area, if you see, OSPF has got many areas. We'll talk about that in later. See, like this. You see area 1, area 2, area 3, and you have a backbone area. Now, within an area, the link state database will be identical.
Yeah.
You cannot expect an identical database between areas. Same database. For example, even though we are all in this earth world, in this one world, the map that we have in our house and map that your friend having in Australia, the world map will be different. Why? The world map that we have will be focusing more on Asia and India.
Right. So in a single area,
the world map that your friend has got in Canada may not have more information about Asia. We'll have much information about the America and Canada and Mexico and sometimes some part of Europe also. Not much information about the Asian countries. But the map that we have will have more information about the cities and countries of Asia and less information about Europe and Western part. Why? Because we are in Asia continent, so more information will be emphasized in the map. But they are in the Western continent. For them, it is more focused on Western part of the world. But the world is same. Likewise, OSPF is this one autonomous system. This is one autonomous system. But the routers in area 1 will have more information about the networks of area 1 and less information of other areas. So within an area, you can expect an identical topology table. Next is the routing table. As we already spoke, the low cost path for every destination is what considered as best path. And this best path will be seen in the routing table. So based on this best path, only the packets get forwarded. So we call this as forwarding database. Routing table is also called as forwarding database. Very good. Now, if OSPF and EIGRP brings information about same destinations, routers will only follow any one of this protocol's recommendation. Which one? It depends on the administrative distance. The routing protocol with the
Sir, one
lower
question. So, for
administrative
example,
distance is what
in
going
my
to be
router I have
preferred.
OSPF as well as EIGRP.
You see, EIGRP's
So,
administrative distance is how
basically like
much?
both, no, like OSPF and as well as
Uh,
EIGRP, they will bring their own route to same
90.
destination, right?
RIPS is 120. OSPF is 110. OSPF administrative distance is 110. Don't forget. OSPF is 110. Now you tell me, when I have RIP, EIGRP and OSPF, which one will be preferred if all three are giving giving routes for a destination? Exactly. Because the EIGRP is Cisco's protocol, Cisco has made that 90 as default, so that EIGRP will be used by people around the globe. But Cisco is not making it as a constant value. If you want, you can change it. You see, when you're running EIGRP and OSPF, and if you want to prefer OSPF, by default it is not going to prefer OSPF. But if you want to prefer OSPF, all that you need to do is go and change the administrative distance from default to some number smaller than 90. The default is 110. But when I go and change it as 85, the routers will start to follow OSPF decision. The routers will start following OSPF decision if you go and change the administrative distance from 110 to 85 or some small. Of course, static route, if you will use the exit interface, then it is 0 administrative distance. If you use the next router's address, then it is 1. So administrative distance matters. Even for the static routing table, you can go and change the administrative distance as 200, so that static route will be less preferred. You can do that. See, for example, whenever the routing table fails, I want the static route to be used. What will I do? If the routing protocol that I'm running is 110,
static route, then it will be having
then for
more
static
priority,
route I will give 150. So that if OSPF is available, OSPF will be used. If OSPF is not available, only then static route will come into the routing table. You understand what I'm saying? Even when I have configured the route won't come into the routing table because OSPF route is preferred. OSPF is 110. But for static route, you have given manually 150. See, in a large network, this is what we do actually. In a large network, we prefer routing protocol. But what if the routing protocol fails? We keep some static route. But by default, static route is 1. Then what I need to do? I need to give the static route with higher administrative distance.
Yeah.
Okay. So administrative distance matters. Only it is configurable. Now, why is this link state routing protocol so important? What is special with this link state routing protocol? As we already spoke, link state routing protocol provides more information about the network than the distance vector protocol. Do you
Static.
agree? Yeah. Than a distance vector protocol, a link state routing protocol provides more information because it sends the complete link status, not just the routing table. So do
Yeah.
you agree with the point, the first point? Okay, second point. Each router has got a full picture of the topology, which is not possible in EIGRP and RIP. Next. Because you got the full picture of the topology, you can make an accurate decision in electing a path. You can make accurate decision in electing a path.
Yeah.
Now, OSPF has got hierarchical network. What is that hierarchical network? Two-tier architecture, two-level hierarchy. One area will be in
Yeah.
the
I mean,
middle and all other area will be connected to it. The middle area, which is connecting all other area,
yeah, correct.
will act as a transit. So it is called as transit area. This transit area is the middle area for all other areas. Like a central government in India. Every state connects to the central. Every state in India has got central tax, state tax. Central tax of every state goes to the central government. And my voice is breaking? Is it clear now? Is it breaking? Okay. It's like a central government in India. That's what I was telling. So every state sends a portion of the tax to the central government. And if there is any flood in a state, for relief, central government gives the money collected from the central tax. So it is only through the central government. The relief amounts are being given. Have you ever seen Tamil Nadu government giving relief amount to Kerala when there is a flood? No. It is only through the central government. That's why
Hello,
we have
your
central
voice.
government. So central government is a transit. If anything you want to give, you give through central government. You cannot give
Hello.
directly because
Yeah,
there is
yeah.
no
Now it's okay.
policy like that.
Now it's okay.
Karnataka cannot give to Tamil Nadu. Tamil Nadu cannot give to Kerala. Kerala cannot give to Andhra Pradesh. Not possible. That is not the policy. Anything you give through central. Likewise. Likewise, in OSPF also, you have one area connecting all other areas. So other areas cannot talk each other. They can talk only through the central backbone area. We call that as a backbone area because it's central. It is like a backbone to the human being. See, in our human body, backbone is the center. If you remove the backbone, no communication happens between the brain and the other part of the body.
Yeah, right.
It is only through the backbone every part of our body connected to the brain.
Yes.
Brain is the central processing unit. If no brain, no movement of mouth, I cannot speak. My eyes cannot understand anything, even if it see the monitor. Even though I see the letters, link state, data set structure, I cannot read this if my backbone is not functioning proper. Likewise, no two areas can communicate without this backbone area. Area 1 and Area 2 can share information only through the backbone area. That is why it is called as backbone or transit or area 0. See, areas are identified with a number.
Yeah.
Areas are identified with a number. The number 0 is only given to backbone. 0 cannot be given to other areas. Only to the backbone area routers, the number 0 is given. Like, what is the pin code number or telephone pin code number of Delhi, you know? I also don't know. Let's take US. America is considered as central to the entire world. Though geographically it is not central. Geographically, Israel is central to the entire world. If you take the entire world,
Got it.
the middle one, the axis, is that mountain, that Jerusalem mountain, for the entire world. That is the right center of the world. But government wise, America is considered as central. See the code number +1. That number 1 is dedicated to US, isn't it? +1
Got it.
is dedicated to America. Likewise, the number 0 is dedicated only for this backbone. I cannot make area number 1 as a backbone. You cannot. That is not the way that OSPF is designed.
Yes.
Number need to be 0 only. Only then it can be a backbone. So, area 0 is a transit area. Next, regular areas. Other than this transit area, other than this backbone area, all the other areas are called as regular area or non-backbone areas. Regular areas or non-backbone areas. So we got transit area, we got regular areas. Other areas can be any number, 1, 2, 3, 400, 10,000. You have 16-bit to write, sorry, you have 32-bit. No, I'm saying a very big number, 32-bit is a very big number. You got 32-bit to identify an area. You can say area 1, you can say area 10,000, you can say 1 million also. Area number as 1 million also you can say. You can say area 555555 because you got 32-bit, no? So OSPF, why do we need areas in OSPF? OSPF has got areas. Why? Why areas? To understand that, let us now talk about our Indian government. Why there is need for a central government and state government? Because, as I said earlier, if you want to share anything to other state, you need one mediator. That is the policy. You give to that middle guy will decide how much to give to whom. Why? Because the need may not be same for every state. For some state there may be big catastrophe. They need more. For some state they may need some roads. But compared to the catastrophe, building a road is not that priority. First is those states that has got some disaster. They need to recover. So only when you have a backbone area, you can share the right thing to other areas. Not only that, you see, for example, there is a big dispute between this Karnataka and Tamil Nadu. What is that? Kaveri water. Kaveri water dispute is there for a long time. It will be there for another 100 years also, as long as this democracy continues. Because they want that reason to run the politics. They don't want
Yeah.
solution actually. They want a reason to fight and create policies. Anyway, politics. Now, what does Tamil Nadu and Karnataka will do? If they want to solve, they would have solved directly, sitting both of them together. But that will never happen. This government will write one letter to the central government. Today we have SMS, WhatsApp, all instant messenger. But they'll say we'll write a letter. They'll write a letter to central government. Likewise, that government, Karnataka, will also write one letter to central government. So, why is that central government there? So that the problem can be no.
Correct.
If these two governments sit
Very well,
together,
yeah.
then they will start fighting. So if it comes through a third party, the fight won't be direct. We can localize the fight. What's the maximum they will do in Tamil Nadu? Those people will go and sit and they'll run the strike for 5 days. Likewise, Karnataka people will strike for another 5 days in Karnataka, saying no, we should not give water. Tamil Nadu people will sit for another 5 days, say we want water. So the problem is solved within the states because of the central government. If there is no central government, these people will start fighting each other because they are very next neighboring states. They know how to go via Osur to fight. Because the central government is in the middle, going to Delhi is too far. So let us fight locally. Everyone will fight locally. Likewise. See, I'm not telling the story here. It's the truth. Here you see there are 4 points. You see the first point. Minimizes the routing table entry. Second point, you see, localize impact of topology change within an area. So any problem, it is localized within an area. Localize the impact of topology. What is topology? When a network goes down, it is localized. See, recently there was a big flood. Even today there was a big flood in Tamil Nadu. In the other state, it is not impacting much. It's a big news only within Tamil Nadu. Others are not going in a boat. Others are going in bus only. But in Tamil Nadu, in some part of Tamil Nadu, they go in boat today because there is full of water. Some houses, the first floor is disappeared. Sorry, they are the only first floor. Ground floor is disappeared. Full water. So they need a boat now. So what I'm saying is, if it is one big country, then everyone would have been worried. Oh, water. Because it is Tamil Nadu, others are cool. Okay, it's in Tamil Nadu, yeah. Not so serious here. That is what called as localize the impact of topology. So if there is some network going down, only that area will be flooded with, that's the next point. Only in that area, LSS will be flooded. That flooding of change, what is link state advertisement? The status of the link. A link has gone down. That is also LSA, going to shoot an LSA. And that LSA will not be going out of that area, will be localized within an area. Okay. Detail LSA, flooding stops at the area boundary. Not only that, if you want to summarize the networks of area 1, I want to summarize all the networks of area 1. Where will I summarize? C, on the C router.
Correct.
Because that is in the border, right? If I want to summarize all the networks of area 3, I'll summarize on E router because that is in the border. Yeah. So you get a nice summarization point because you got area. If you don't have areas, you won't have summarization point, isn't it? So areas are important. See, if you don't have Karnataka, Tamil Nadu, then you won't have the border called Osur. What is the border between Kerala and Karnataka? Why I'm asking is my next trip is
Correct.
Ernakulam. I am coming by road. I want to know the border.
Yeah.
Oh, like that. Okay. Okay. So, hmm. Oh, yeah. I know that road. Okay. In Mysore, I have seen. Correct. Ooty, you can go via Ooty, isn't it? Something like that. Hmm.
I'll summarize
Okay.
at
So there is no direct
area only.
border for Karnataka and Kerala because it's in different location. But for
Yeah.
Tamil Nadu and Karnataka, there is one border. Osur. Okay. So because you have
Here out. Yeah.
areas, you
Border.
get a
Yeah.
border. Because you have a border, you can summarize and say this side is Tamil Nadu government rules. This side Karnataka rules. Rules may be slightly varying.
Yeah.
Terminologies. See, the border routers are called as ABRs, area border router.
Kerala and
In our topology, there are
Karnataka.
three ABRs, C, D, and E, isn't it? C, D, and E are they border?
Okay.
Yes, they
So
are in the border.
you are going through
C, D, and E are in the
Hosur
border.
only, no? So
They
Hosur,
are area
Salem,
border routers,
like
C,
that
D,
you
and
can go right
E.
to
Why
Ernakulam.
they are called as
That is the connection.
ABRs? If you
Yeah.
see router C,
Otherwise, you may
one
have to
link
go
is
through
down. In which
Mysore
area?
Road,
Area 1.
this Wayanad. So that
Other link is connected to B router. Which area? Area 0. So if you have a router
yes.
which has got one link, at least one link in area 0 and other link in other area,
Hmm.
then it is called as ABR, area border router.
Yeah.
One link should be at least one link should be in area 0. Only one link. And the other links can be in other area or multiple areas, never mind. So here C, D, and E are area border router and A and B are internal to backbone. So they are backbone routers. A and B are backbone routers because they are fully inside area 0. Is B a border router? No. If you notice B, the complete 4 interface is in area 0. So it is a backbone router.
Yeah.
It's a backbone router. And F, G, and H, you can call it as internal routers. F is internal to area 1, G is internal to area 2, H is internal to area 3. I was telling you in OSPF, hello packets are sent every 10 seconds. Now, to discover neighbor, there should be some hello, isn't it? And this hello is sent
Okay. Got it.
every 10 seconds to a particular address, which is 224.0.0.5. Correct. 224.0.0.5. 224.0.0.5 is the multicast address OSPF uses to talk to other OSPF running router. See, you are let's say you are in a French country. You and your family went to a French country.
No.
French speaking people. French, let's say French, Spanish, English,
That's what.
but none of them there knows Malayalam. Only your family member knows Malayalam there. So, if you want to speak to only your family member, will you speak in Spanish? No, you'll speak in Malayalam. Even though French people can hear the voice that you are speaking, even though the Spanish people can hear the voice that you are speaking, will they will they take it and process it? No,
Yeah.
because they don't understand. Because they know that this don't belong to them. What you speak is not for them. They know it. So they ignore. Even though they can hear your voice, they understand nothing. Only your family member understands and your family member reacts.
Multicast, right?
Right. So when you speak in Malayalam, even though there are 100 people in that place, only your family member responds to that voice. That is how multicasting also works. Not only Malayalam, all MM only it starts. You see, multicasting Malayalam, both M. Okay, anyway. So I'm trying to explain you how multicasting helps to talk only to OSPF running router. You may have many routers running various protocols, but only OSPF running router will receive a hello. How? Because 224.0.0.5 is the language of OSPF. Only OSPF routers can understand the packets that you send to that address. Others will receive the packet, but they don't understand. They drop it. Others will receive the packet, but when they see that address 224.0.0.5, they ignore it. Same like what, Correct. Because they don't know Malayalam. Because they don't have OSPF. Others will listen, but Sugamano, they don't understand what is Sugamano. So they ignore. Maximum they will smile at you, that's all. But they really don't understand. You are asking, how are you? They'll simply smile. All right. So hello packets are important here to discover neighbor. Not only that, after forming neighbor, to establish, to continue establishing neighbor, you need hello packets. Now, as I was telling you earlier, there are certain parameters that are shared in the hello packets,
5.
which will be compared, and only if those parameters matches, one router will agree the other router as a neighbor. All right, there are certain parameters which we'll be seeing in the next chapter. One is area ID. Area ID must match to form neighbor. Area ID must match. For example, if you see the previous picture, the C router will send a hello packet with
Because they don't have
area 0
OSPF.
only. This link is in area 0, no? This will say area 0. This will also say area 0, so they form a neighbor. Here, this will say area 1. This will say area 1. They form neighbor here. Area ID must match to form neighbor. And the area ID is with respect to interface, not with respect to router. You see, if it is with respect to router, then this two will not form neighbor. In this link, it is area 0. In this link, it will send area 1. Same router, sending different hello. One is saying, I'm area 0. Another link is saying, I'm area 1. That is why ABR router. They are called as area border. We'll talk about the parameters later, which is coming in the next chapter. Right? So I think we'll stop here today. We'll
Mm-hmm. Yeah. Mm-hmm. Okay. Mm-hmm. Mm-hmm. Yeah, yeah. Sure, okay. Yeah, bye. Mm-hmm. 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 Yeah. Mm-hmm. Mm-hmm. Okay. Sure. Sure.